Good morning to all the viewers of international and also from India. We welcome for this international webinar series on open source digital technologies towards self-reliant India, Atmanirbhar Bharat. On behalf of the Chancellor and Vice Chancellor of the Soviet Institute of Engineering and Technology, Meerut, a NAC accredited deemed to be university, we organize this international webinar series on open source digital technologies towards self-reliant India to facilitate startup India in the open source digital technologies in India. Center for Informatics Development Solutions and Applications, CIDSA, Center for Agricultural Informatics E-Governance Research Studies, Center for Agribusiness and Disaster Management Studies, and Center for Industry 4.0 Technology Studies and Application of the Soviet Institute of Engineering Technology, Meerut, are engaged in providing technological services and technology education research and training to the students from rural India. In this international webinar series on open source digital technologies towards self-reliant India, the Center for Excellence, CIDSA, has organized so far 6 lectures, namely Open Technologies to Provision Simple and Economical IT Infrastructure, which was held on 12th September 2020, addressed by Dr. B. Balasubramanian, former Deputy Director General, National Informatics Center, and Head, National Informatics Center, Open Technology Center, Chennai. The second lecture was on 18th September 2020 by Dr. B.K. Mishra on a roadmap for students using free and open source software and reaching goals of Atmanirbhar Bharat. Dr. H.K. Sugas, former Deputy Director General, National Informatics Center, on 25th September 2020, delivered a talk on open source software and industrial IoTs for SMEs. On 3rd October 2020, Mr. M.R. Rajagopalan, former Director, Center for Development of Advanced Computing, Chennai, and Director of National Resource Center on Free Open Source Software, Chennai, has delivered a talk on free and open source software adoptions and business models. On 10th October 2020, Madam Alka Mishra, Deputy Director General, National Informatics Center, delivered a talk on Open Data Platform for Smart Digital Government. On 17th October 2020, Dr. Kamlesh Kumar Bajaj, Founder Director, Certain, Ministry of Communication and Information Technology, and Founder CEO, Data Security Council of India, and former Deputy Director General, National Informatics Center, delivered a talk on technology imperatives, Make in India for Self-Reliance. Today, we will have the talk by an eminent technocrat of the country, Dr. Pethuru Raj, Chelliah, Chief Architect and Vice President from Reliance Geo Platforms Limited on Edge AI. Dr. Pedro Raj Chelliah is working as a Chief Architect and Vice President in the Site Reliability Engineering Division of Reliance Geo Platforms Limited, Bengaluru. His previous stints are in IBM Global Cloud Center of Excellence, Wipro Consulting Services, and Robert Bosch Corporate Research. Dr. Pethuru Raj Chelliah has gained more than 19 years of IT industry experience and 8 years of research experience. Finished the CSIR-sponsored PhD degree at Anna University, Chennai, and continued with the UGC-sponsored postdoctoral research in the Department of Computer Science and Automation at Indian Institute of Science, Bangalore. Thereafter, he was granted a couple of international research fellowships to work as a research scientist for about 3 to 5 years in two leading institutes, universities in the country. Dr. Pethuru Chelliah has published more than 30 research papers in peer-reviewed journals such as IEEE, ACM, Springer Verlag, InterScience, and etc. He has authored and edited more than 20 books and contributed 35 book chapters for various technology books edited by highly acclaimed and accomplished professors and professionals. Dr. Pedro Raj Chelliah focuses on some of the emerging technologies such as Internet of Things, artificial intelligence, big and fast data analytics, blockchain, digital twins, cloud native computing, real-time computing edge through edge and fog analytics, containerized clouds, microservices architecture, event-driven architecture, etc. His personal website is at https://sweetypeterdarren.bigsite.com/Pethruraj books. Before I request Dr. Pedro Raj to deliver his talk, I would like to give some brief introduction about the theme of this series. So far, this webinar series discussed in the area of technology imperatives, open systems, open infrastructure, open source software for open infrastructure, open hardware for open infrastructure, open data and open data platform, human resources development, startups in open technology, open society, society 5.0, industry 4.0, example pharma 4.0, textile 4.0, agriculture 4.0, and now today edge computing and edge artificial intelligence. Atmanirbhar Bharat, self-reliant India, is the vision of the Prime Minister of India, Shri Narendra Modi, of making India a self-reliant nation, rested on 5 I's: intent, inclusion, investment, infrastructure, innovation, and based on 5 pillars, namely economy, quantum jump, not incremental, infrastructure, one that represents modern India, system, 21st century technology driven, vibrant demography, source of energy for self-reliant India, demand, whereby the strength of our demand and supply chain should be utilized to full capacity. This Atmanirbhar Bharat Abhiyan Yojana was announced on 15th May 2020 by the central government through a special and comprehensive economic package of rupees 20 lakh crore that accounts for 10% of India's GDP to bring the economy back on track. Vocal for local to make it global, a demand-based economy system which is self-producing and self-consuming. These reforms announced have been systematic, planned, integrated, interconnected, and futuristic for creating strong enterprises, generating employment, and robust supply chain. This is our intent. Today, Dr. Pethuru Raj Chelliah will talk about Edge Artificial Intelligence, Edge AI. What is Edge AI? It means that artificial intelligence algorithms are processed locally on a hardware device. The algorithms are using data, sensor data or signals that are created on the device. A device using Edge AI does not need to be connected in order to work properly. It can process data and take decisions independently without a connection. During the last decades, we have seen how data is migrating, first from on-premises to cloud data centers, and now from cloud to the edge points closer to the source where it is being generated. With this small introduction, and now I will request Dr. Pedro Raj to deliver his talk. Dr. Chelliah, over to you.
Yeah, thank you so much for the introduction.
Please adjust your your head is split. Your head is not visible. Okay, fine. Now, all right. Thank you.
So, are you able to see the presentation?
Yes. Yes.
Okay.
It has come.
Yeah. So, I'm Peter. I work for Reliance Geo Platforms Limited, based out of Bengaluru. So we are working on a variety of digital transformation, digital innovation technologies. So I will show, okay, so this is the agenda for today's talk. I will talk about edge computing, edge cloud, edge analytics, and intelligence at the edge, and the arrival of artificial intelligence specific chips for edge devices. Then I will throw some light on cloud native edge computing, and some of the industrial use cases related to edge computing. Okay, so these are some of the prominent digital technologies that are at least leveraged in the IT industry today, and academia is also sincerely following that. So you will hear more about these technologies in the days to come. For creating such a real digital transformation, these technologies have to be meticulously leveraged to develop applications, digital living application, digital transformation applications. So predominantly artificial intelligence will play a very, very vital role over there in the future in order to come out with the digital applications. Then analytics part, we have big data analytics, fast data analytics, streaming data analytics. Then blockchain technology is coming up very fast for ensuring the security for the data, and blockchain databases will represent the single source of truth for all kinds of digital data that are getting generated by various devices at the ground level. Then IoT, Internet of Things, I will throw some light on that. Then mobility, 5G and Wi-Fi 6 and 7, digital twins, cloud native computing, so edge computing. Then on the architecture side, we are primarily using microservices architecture and event-driven architecture. Some of the newer use cases include augmented and virtual reality, and cybersecurity is another interesting phenomenon for study and research. So these are some of the digital technologies. Today, I will talk about the edge computing and the artificial intelligence, how they converge with one another in order to come out with very prominent next generation digital applications for the society, for the business, for the individuals, for the people. Okay, so with the digital technologies flourishing everywhere, it is forecast by the various market watchers and analysts like IDC, Forrester, Gartner. They are telling that by the year 2020, there will be millions of software services, that is, millions of microservices, then billions of connected and cognitive devices, then trillions of digitized entities. These are the forecast for the year 2020. Maybe due to this pandemic situation, this number may not be realized by this year end, but at least we can expect all these things to happen in the years to come. Okay, so I will throw some light on that. Before that, I will tell something. I will start with IoT, because already you had a lecture on IoT. But for clearly illustrating what is edge computing, if I put a foundation on IoT, it will be useful for you people to understand the foundation as well as the fundamental thing behind edge computing. So we are all know about these computers are getting integrated with one another. So if we type timesofindia.com in my browser, I can see the Times of India news, even though the Times of India website is situated at some other place. That means my laptop is connected to the Times of India server. So that is Internet of Computers. That happened several years back. Next in place is Internet of Devices. Okay, so all our devices are getting connected with one another as well as with the internet. The point is this: we have 7 billion people in the planet Earth. Out of that, 5 billion people are using mobile phones. Out of that, 3 billion people are using smartphones. That means already billions of people, devices are getting connected with the internet as well as with one another. There is no need for waiting till the year 2020. In 2017 itself, we had 3 billions of smartphones across the globe. Okay, so but that is not the point. Not only smartphones, but all other kinds of devices in our everyday environments, in our homes, in our hotel, in our hospital, retail store, manufacturing floor, whatever environment you take, there are variety of heterogeneous devices. These devices are meticulously getting integrated, hooked with internet as well as with one another. So that is why I have talked about connected devices. So KHP has come out with the result with the forecast saying that by 2022 there will be 33 billions of connected devices across the planet Earth. Okay, 33 billions of connected devices. So why devices have to be connected? I used to tell this example everywhere. So I read it in a magazine. So Samsung has come out with the connected refrigerator. That means web-enabled refrigerator or cloud-enabled refrigerator. So when I say cloud-enabled, web-enabled, that means that represents the same thing. After the popularity of this cloud computing, we no more use the word web. So when I say web or cloud, it is web integrated, web connected, web enabled. Okay, so this connected refrigerator, what is the advantage? When the milk quantity inside the refrigerator goes down below the threshold, automatically the refrigerator will give a ring to the milk vendor saying that the milk quantity has gone down below the threshold, so please supply 2 liters of milk. And on the other side, suppose if you are in the office, in the evening time when you start your journey back to home, you can see what are the items that are not sufficiently found inside the refrigerator at home. Through your cell phone, through your smartphone, from the office itself. So on the way back to your home, you can go to a supermarket or some retail store to buy those items. So you can come home happily with all the relevant and right items that can be incorporated, that can be put inside the refrigerator. So you can think so many other things when things are getting connected with one another. Okay. So another interesting example is suppose the gentleman is watching TV inside the home. There is a security camera that sits outside the home. Somebody is coming to your home. That security camera that is situated outside your home capture the image of the person who is coming into your home, and they pass on that image to the corner of the TV because the person is watching TV. Now, the person who is standing outside the home is a known person. Then this gentleman, the house owner, can orally instruct the door to open. Okay, so think about that security camera talking to TV. Today, that is not possible. It may be looking like a fancy thing, but there are technologies, there are adapters, there are connectors, there are middleware that helps to merge these two different data transmission protocols so that security camera can talk to TV. So you can think such kind of innovations connecting heterogeneous devices so that you can get better things, bigger things in the days to come. Okay, so today we are getting very small and simple thing, but when things are getting connected, you can clearly expect bigger things tomorrow. So it is a challenge, but at the same time, the things are getting connected, devices are getting connected. So all kinds of devices are, because they are getting connected, these devices can become intelligent. For example, these robots are getting connected. That means it can do surgery at the hospital when things robots are getting connected with internet. Remote surgery is possible. Teleconsultation, telemedicine, telemonitoring, telediagnosing. These are all some of the things that are getting accomplished when things are getting connected with one another. Okay, I can go on listing of such kind of use cases, but considering the time limit, I don't go deeper into these things. So to be precise, we started with Internet of Computers, then we entered into Internet of Devices. Okay, not only our home devices, but all kinds of devices in our everyday environment, in our personal environment, in our professional environment, in our social environments. Every device, every electronics, every instrument, every equipment, every machinery, every appliance, every utility is getting connected with one another, as well as with the applications that are getting hosted in cloud. So there are a variety of applications and services and databases that are getting installed, incorporated in cloud environment. Now these are getting connected with the ground level identity. That's why you might have heard about another concept called cyber physical systems. That means all your physical entities and the elements at the ground level are getting connected with the cyber application, so that the devices get extra capability, extra competency, extra feature and facility and functionality to accomplish the contest our applications. These devices, because of their empowerment, because of their enablement, can understand what is the contest in which you are in, and accordingly it will create the services required relevant for that particular person, and it will deliver the services in time, so that the person who will be clearly empowered through these contested, connected, embedded network devices. Okay, so there is about the billions of connected devices, then the trillions of digitized entity. That means not only our devices, but also all our common, casual, cheap things in our environment will get connected with the internet. For example, our windows, our cart, our chair, our table, our sofa, everything gets connected with the internet. Why our windows has to be connected with the internet? Again, deeper automation. The window will understand what is the outside temperature, what is the inside temperature. Accordingly, it will decide whether to keep the window open or closed. Okay, so that means delegating our task to these digitized entities. So, as I told you sometime back, the person, when he was sitting on the sofa, the TV is starting. How the sofa is starting to TV. Okay, so now suddenly there is a phone call for the gentleman. Now the phone will tell the TV saying that there is a phone call, so please reduce your volume. That is possible. Think about the possibilities and opportunities available with the connectivity. Your sofa is talking to TV, your cell phone, your smartphone is talking to TV. So the possibilities are endless. So that is the way this connectivity phenomenon paradigm has come out with a variety of use cases, not only for personal use cases, but also for business use cases, industrial use cases. Okay, so here why I use the word trillions, it is projected that by our leading market analyst group, saying that there will be trillions of such kind of digitized entities. All our common, any tangible, any concrete things will become digitized. Once upon a time, we used the word computerized. Today it is we are using the word digitized. Okay, so how digitization happens? There are so many digitization technologies. There are so many edge technologies. For example, sensors, actuator, chips, tags, stickers, barcodes. Okay, LEDs, beacons, okay, smart dust, specs. These are some of the microelectronics, nanoelectronics entities that will enable any ordinary entity to become an extraordinary entity. Any dumb element into active element or animated thing. Okay, so by incorporating such kind of edge technologies or digitization technologies, as I told about sensors, such kind of things, you can empower any ordinary thing into extraordinary thing, into digitized entity, into IoT entity. Okay, so what does it mean? When you put a presence sensor on your sofa, when you are sitting on the sofa, then the presence sensor will understand somebody sitting on the sofa. Then the presence sensor in time will tell the TV to start. to initiate its task. Okay, so that is about digitization. So by incorporating any kind of appropriate digitization technologies, for example, you can put a RFID tag on your shirt. So your shirt will become e-shirt or digital shirt. What is the advantage? When I throw my digital t-shirt tomorrow into washing machine, this t-shirt will tell the washing machine that this fellow used this t-shirt consecutively for 2 days. So please go for deeper washing. Okay, so that is the possibility. So this is a kind of digital entity. That's why I use the word trillions. Anything and everything will become a digital entity in the days to come. So we started with the Internet of Computers, then we started with talked about Internet of Devices. Okay, then third one is Internet of Services. So if you are coming from computer science background, you might have heard about service-oriented architecture several years back. Okay, maybe 10 years back. But today that is not the case. Today everybody is using the word microservices architecture. That's the offshoot of service-oriented architecture. MSA is the predominant, dominant application architectural pattern, application architectural style that can be used for developing your microservices in an agile manner. Okay, so MSA is a mechanism for creating your application in an accelerated manner. That is agile design technique, agile development technique. So using MSA, you can design your application very fast. Using MSA, you can develop your applications very fast. So designing and developing your applications in a faster manner can be accomplished through the leverage of microservices architecture. Okay, why it is so important? Once upon a time, if a business wants to develop an application, they will approach one of the leading system integrators like Wipro, Infosys, TCS, Cognizant kind of companies, and these people will start with the requirement solicitation and engineering, then they will start with high-level design, low-level design, then development, then debugging, then delivery, then deployment, then decommissioning. So it's a long process, correct? It will take months of time. For even a small and simple application, such a long time will be consumed by our service organizations. So that is not the case anymore. Business houses are not willing to wait for such a long time. They want everything immediately. So how to transition from months of time to minutes of time? So that is the challenge here. So microservices architecture comes into picture here. How? Once upon a time we created applications using objects. So object-oriented programming means multiple objects talking to one another, collaborating with one another to create an object-oriented application. So objects is the building block for application. Then we moved into a component-based assembly, then aspect-oriented programming, agent-oriented programming, then what else? Service-oriented programming. Today, it is microservices-oriented programming. That means all kinds of microservices are already developed by somebody, and they are deployed in open source software repositories. Okay, microservices architecture is a polyglot architecture. That means it is technology neutral, technology agnostic. Any programming language can be utilized for developing such kind of microservices. Okay, so if you want in Java, if you want Kotlin, if you want in Scala, if you want in Rust, if you want in Python or Java or whatever language, there are so many programming languages. Any language you can use for developing your microservices. All these microservices are already developed and refined, curated, tested, and deposited in open source software repositories. A software engineer, instead of starting from public static void main, he or she can go to this public repository, collect those relevant microservices. There are automated composition tools, orchestration tools, or choreography tools that will help you to compose these microservices to form an application in minutes of time. So microservices architecture not only speed up the process of designing an application, but also it will speed up the process of developing, building, implementing your applications very quickly. How it is, because already almost all the relevant microservices are developed in different languages and they are made available freely for any software developer across the globe to find and to pick those relevant right microservices, compose them, combine them, cluster them, club them together, create an application in minutes of time. That is the possibility with microservices architecture. So in future, all other enterprise scale application, cloud application, mobile application, IoT applications, blockchain applications, data science application, artificial intelligence application, whatever applications you need, all these applications can be developed as a collection of interactive microservices. These microservices are already available. Pick the relevant microservices, combine them, get an application immediately. For example, we all know about Flipkart. Flipkart is a massive B2C, business to consumer e-commerce application. It's a massive application. It has more than 1 lakh of lines of code. It is such a massive monolithic application. Okay. So as far as my little knowledge is concerned, these e-commerce service providers are slowly moving towards microservices architecture. What is the advantage? There are so many advantages of leveraging microservices architecture. If I list out them, it will take a lot of time. So here, when a Flipkart kind of e-commerce application gets segmented into a collection of, into a pool of microservices, you will have several thousands of microservices out of one single monolithic application. For example, think about shopping cart microservice, warehousing microservice, notification microservice, analytics microservice, shipping microservice, shopping microservice. You can think about that. So these are all the microservices. Combine them, you will get any kind of e-commerce or e-business, any application that can be accrued out of microservices through clustering, through clubbing together. Okay. So Internet of Services means all your services are microservices are already developed and they are made available across software repositories, and the software engineer has to go to these microservice repository, collect them, combine them, then create an application very quickly. So that is Internet of Services. Okay. So that's why I have written millions of software services. Okay. That includes all kinds of enterprise services, embedded device services, IoT services, artificial intelligence services. So all kinds of services are already available and they are being leveraged. And if there are any limitations, lacuna, then that are being attended. And these services can be developed using any kinds of programming languages, and they can communicate through the network using any one of the communication protocols. Okay, so GPRC is leveraged for higher performance. RESTful APIs are used that works on HTTP protocol. So all the protocols are being supported by these microservices, so that any application that needs some sort of high performance, that's a customer facing application. Accordingly, they have to choose which protocol, which data format they want to use. They can use it. So that is Internet of Services. Fourth one is Internet of Things. So I told about Internet of Computers, Internet of Devices, Internet of Services. Services are available across multiple servers across the globe. You can collect them and create application. Internet of Things is, as I told you, all our things in our everyday environments can also talk to internet, can also hook to internet, so that our things will become digitized entity. Okay, that is called Internet of Things. So the Internet of Things means all our things, very common casual things, will get internet connectivity. Okay, so the Internet of Things. So so I talked about that. Now I will talk about artificial intelligence and some of the analytics. Okay, so Internet of Things typically is a data collector. For example, GE is the world's largest.
Professor Pedro Raj, the slides are not moving. Just to see. Okay.
Okay.
It is still in the first slide.
Okay, so whatever I have told about this digitization technology that you can see here, okay, actuators, beacon, chips, codes, all these things, some of the miniaturization technologies, device ecosystem is growing rapidly. So I talked about connected devices. Okay, so here IoT, as I told you, Internet of Things is a data collector. Okay, what does it mean? It collects the environment data. It collects the data of the entity on which that IoT device is attached. For example, GE is the world's largest producer of aircraft engine. I was told there are 800 sensors are attached in each of the aircraft engines. Okay, so when a flight that starts from Mumbai to New York, after 18 hours of travel, when the flight lands in New York, these 800 sensors that are embedded on the aircraft engine would have generated 30 terabytes of data on the various aspects of that engine performance. Okay, I'm not compatible with that, the functionality of engine. So typically an aeronautical engineering guy can easily understand most of the functionality. So these sensors collect a lot of data about the engine. Okay, so what the data scientists in GE will do, they will collect all the 30 terabytes of engine data, and they will subject that data into a variety of investigations in order to understand what is the performance of that engine on the way from Mumbai to New York. What is the total performance? So still that GE person told me only 65% performance is being achieved by aircraft engine. Okay, so they are still trying to come out with some newer technology so that they can enhance the engine performance. Okay, why they are taking this performance data? When they go to prospective customer, they are saying that our engine can get 65% performance, whereas our competitors do not come near to our level. Okay, so data are very important. We cannot throw out any data. So we usually hear about that data is an asset, data is a new fuel for our nation, data is like in bank, we go to their customer is the boss. We can read that statement, customer is the boss in bank. Similarly, in future, data is the boss, data is the customer. Okay, so so what these data scientists are doing, they are making out of the data. Similarly, they are making sense out of the data. So we cannot throw out any data. Instead, we have to carefully, consciously collect all kinds of data to extract some kind of actionable insights out of that data. Okay. So what I'm trying to tell is these sensors are attached on devices. So the sensor collected a variety of information about that engine. So when we say IoT, IoT is a collection of these kind of sensors, actuators, chips, codes, stickers, and this will collect a lot of data from their environment. If you put a sensor like heat sensor, temperature sensor, gas sensor, pressure sensor, presence sensor inside your home, it capture all kinds of sensor data from your phone. So by that data, if you are using data fusion algorithm, it is possible to decide whether there is any possibility for fire at the phone. Okay, so sensor data is very important, and sensor data is captured from the environment. Not only from the environment, if a sensor is attached with the equipment, with the appliance, with the machinery, with the device, with the equipment, with the utility, then it will capture all the details about that utility, that equipment, that machinery. Okay, so two primary jobs are being done by such kind of IoT sensors. Okay, so sensors collect data from the environment as well as from the devices on which these sensors are embedded or attached externally. Okay, so IoT is simply data collector. Okay, IoT is simply data collector. It will collect the data, and if you are using IoT gateway inside the home, that data can be captured by the IoT devices, IoT sensors. These IoT sensors will send the data to IoT gateway. IoT gateway also inside your phone, because sensors do not transmit the data more than 20 meters. Okay, so their range is very short. So you need a IoT gateway there. It can be Arduino board, or it can be a Raspberry Pi, or any kind of broker or hub, or any gateway. Wi-Fi gateway also can act as an IoT gateway. Okay, IoT gateway is the single point of contact for all the sensors that are situated inside that room, inside that home, inside that hospital, or inside that retail store, wherever it is. All the sensors, heterogeneous sensors will talk to this IoT gateway. IoT gateway has a WAN module so that it can connect with the cloud application. Your cloud may be in Mumbai, your cloud may be in Delhi, or your cloud may be in California, your cloud may be in Singapore, or Sydney, or Tokyo, or Ireland, or Hong Kong, whatever it is, it can send the data to that particular cloud application situated at the cloud center, cloud environment. Okay, so why I am insisting the point, IoT is just a data collector and a data transmitter. Okay, so now in order to make sense out of the data, in order to make money out of the data, we need some sort of analytics platform that has to run on any one of the cloud center. Okay, so we have extensively heard about big data analytics, or fast data analytics, or streaming data analytics. Okay, even nowadays we are hearing about the word cognitive data analytics platform. Okay, so these data analytics platform collect all the data sent by this IoT gateway, and it will do the crunching on that. Why analytics is very important? I tell you a very interesting story here. It's a real thing happened several years back. Okay, so analytics is important. Way. So some 20 Israelites from Israel, they wanted to go for a vacation in Spain. Okay, so somebody wanted to kill all those 20 Israelites. This fellow was waiting inside the Spain airport, waiting for the flight to arrive from Tel Aviv. Okay, so this guy was wandering inside the airport. All the CCTV cameras that are there inside the airport are capturing the images of the person who are wandering inside the airport. All the images were captured and stored in the image database. Okay. Now, this flight that came from Israel, the people came out of the airport. There was a bus waiting outside the airport, and these all the 20 Israelites entered into the airport and into the bus. And this guy committed suicide in front of the bus, and he killed himself also. He killed all the 20 Israelites on the spot. Okay, so the point that I want to make here is, if the images that were captured that person. Okay, okay, so yeah. So I will talk about that when I talk about data analytics. These images were captured and stored in a database. What they have not done, had they done that analytics on the image data captured from all the CCTV cameras that are inside the airport, the analytics platform would have told the policeman in the airport, saying that there is something mysterious about this guy, whom also please catch hold of him and interrogate him. So had they done the analytics, this disaster could have been avoided. Okay, this disaster could have been avoided had they done the analytics in time. So analytics is very important. You can capture all the data. If you don't do the crunching, if you don't do the analytics, if you don't do the mining on the captured data, then there is no use. Okay, so every kind of data, whether it is internal, external, has to be captured meticulously, and they have to be cleansed, and they have to be crunched immediately, so that actionable insights, intelligence, knowledge can be extracted out of that data. Okay, so that insight should have empowered the concerned people to plunge into action immediately, so that any kind of disaster could have been avoided well in time. Okay, so analytics is very important. So that's why I used to write big data analytics, real-time analytics, or fast data analytics, and streaming data analytics. Okay, so that is one aspect. So another aspect is artificial intelligence. Okay, artificial intelligence. Okay, so so I don't have slides for artificial intelligence, but I will show something later. Okay, so thing is, I would like to tell the difference between artificial intelligence and analytics platform. As I told you, big data analytics platform are there. You all know about Apache Spark, Apache Hadoop, Apache Samsa, Apache Flink, Apache Storm. Then there are commercial grade analytics platform. Okay, so analytics platforms are plentiful. Okay, now typically analytics platform need two ingredients. One is you have to give input data, and you have to write the logic how to process that data. Okay, two things are needed for activating your analytics platform. That is, you need data, you need input data, then you need processing logic. Okay, now come to artificial intelligence. Artificial intelligence typically comprises machine learning algorithm, deep learning algorithm, computer vision, and natural language processing, NLP. Okay, now these machine learning, deep learning algorithms are typically do not need any coding, any logic. You give the input data, everything else is being taken care of by this machine learning, deep learning algorithm. That's the power of artificial intelligence. Whereas in the case of analytics platform, you have to give the not only give the data, but also you have to write the logic. Whereas in the case of artificial intelligence, there is no need for any logic to be incorporated, to be written, to be coded. Okay, so that is the bigger advantage of artificial intelligence. Second advantage, typically the analytics platform will tell what happened in the past. Okay, what happened, how it happened, why it happened, all these things you can get out of analytics platform. That is, it will do deterministic, it will give deterministic insights, it will give diagnostic insights. Okay, so but in the case of artificial intelligence, it will talk about future. What will happen tomorrow? What will happen next month? What will happen next quarter? Okay. In summary, it will give predictive insights, prescriptive insights, and personalized insights, and prognostic insights. These are some of the insights that you can accrue out of artificial intelligence. So there are mainly two differences. One is two ingredients are needed for analytics platform, but data is sufficient for artificial intelligence platform to take further action. And another thing is analytics platform typically talk about the past things, whereas artificial intelligence typically focuses on futuristic things. Okay, so yesterday I was talking to somebody, so I told this. So in foreign countries, especially China and South Korea, and they are able to control this COVID-19 very fast compared to other countries because of their extensive usage of artificial intelligence technology. Okay, at least in the foreign countries, the advanced countries, the number of doctors is very less compared to the number of patients. So every patient cannot go and meet the doctor in person. Okay, so that's why this CT scan or lung scan, whatever it is, this scan can be given to artificial intelligence app that will clearly articulate and tell whether you have COVID-19 or not. Okay, there is no need for any physical movement or physical interaction with the doctor. Instead, everything will be done through app and artificial intelligence application. Okay, so there are many advantages of artificial intelligence. Okay, there is a major difference between artificial intelligence and big data analytics. Now I told about IoT is a data collector and transmitter. Now, not only collecting the data, not only transmitting the data, but also the data have to be crunched in order to extract actionable insights in time. So here, both the analytics platform as well as artificial intelligence toolkits like TensorFlow, PyTorch or something like that. There are so many, around 40-odd artificial intelligence toolkits are made available these days, and these toolkits help to make sense out of all the IoT data. All the data submitted by IoT devices, IoT sensors, IoT actuator, IoT equipment. Okay, so that is the need for artificial intelligence. So this IoT combined with the artificial intelligence will be a deadly combination for the future of the society. Why? Because one is data collector, another one is a data cruncher, okay, data analyzer, okay, data investigator. Okay, so when we subject IoT data into a variety of investigations, we will get a lot of knowledge. That knowledge discovery can be accomplished through these artificial intelligence toolkits, and that knowledge dissemination can be accomplished through a variety of dashboards, okay, knowledge visualization toolkits or business intelligence toolkits. There are so many, okay, Tableau, ClickView is there, Sisense is there, Microsoft has BA tools. So there are so many tools that will clearly articulate through graphs, charts, maps, okay, what is the situation. So at one end, at the ground level, you have IoT devices that collect all the data about people, property, and the actions that are happening in that ground level, that gets transmitted through 5G network to the cloud. Cloud may be in Mumbai, maybe in Delhi, maybe in Kurgan. Okay, and there in the cloud you have artificial intelligence platform running, and the artificial intelligence platform get all the data submitted or shared by these IoT devices. Then the crunching happens in the cloud. Now, once that analytics gets completed, then the insights extracted out of the data that will be given to the concerned person to act upon with all the clarity and care. Okay. So what I'm trying to tell is data generator at one end and knowledge generator at another end through artificial intelligence. So IoT alone cannot do anything because it will just generate the data, but unless otherwise you subject the data in a variety of investigations, analytics, mining, learning, then there is no point in collecting data. Okay, because there is the process of converting the data into information into knowledge is being speeded up through the variety of accomplishments and advancements in the technology space today. Okay, so technologies are there, they are very stabilized, matured. These technologies help to make sense out of data. That's why bigger organizations have data lakes. As far as my little knowledge is concerned, Jio has a very massive data lake setup. It has around 3,000 servers, multi-processors and servers. And if I'm not wrong, 1 billion plus Jio devices alone will be there in India, and they will generate 150 petabytes of data every year. Okay, every year 150 petabytes of data will be generated by Jio alone. Now think about our competitors. Okay, so there will be the huge amount of data, massive amount of data will be generated. No company will throw out the data anymore. But sadly, today even with Apache Hadoop, only 2% of the total amount of data that are getting generated across the globe are subjected to this analytics. Okay, in the days to come, more amount of data will be subjected to analytics, so that more amount of insights. Big data will give big insights. Correct data will give correct insights. Okay, so technologies are there in place. So we cannot throw out any data. Instead, consciously, carefully collect all the data, store all the data, subject that data to analytics, extract the insights, share the insights to the decision maker, to the concerned system in an automated manner, so that there will be very less manual intervention, manual instruction, manual interpretation. Okay, that is the era we are going towards. That is called automated analytics. So I forgot to say that the difference between analytics and artificial intelligence is this. AI is called automated analytics. Okay, so if you go to IBM website, they use the word cognitive analytics. Cognitive analytics is also a kind of automated analytics. Why? Because if there is a cancer patient goes to an hospital, and if there is that Watson Healthcare platform, that's a cognitive analytics platform is there, then just to give the blood report, that is more than sufficient. Then Watson will come out with all the details. Okay, whether you have cancer or not, if it is if there is no cancer, whether there is any possibility for cancer at the age of 40 or 50. If it is a cancer, what sort of cancer it is. Then what sort of medication you got to go through, all these things. There are several use cases, interesting use cases that are there in IBM website. I can quote a number of use cases, but already it is time for 1 second. What's the time now? So 12:24. I think I have to finish another half an hour or 45 minutes. I will finish it. Okay. So lot of use cases are there. So AI is
please carry on. No, you have time up to 1 o'clock. Okay.
Okay. So I will exactly finish at 1 o'clock. Okay. So automated analytics. So now I will jump into the main topic, edge computing. You can see the picture here. What's the difference between edge computing and cloud computing? Okay, as I told you, all the when I say digitized entity, that entity is getting connected with the cloud application. As I told you, cloud may be in some other place through an IoT gateway. These devices are getting connected with the internet. Okay, now come to the second picture, down picture. No device is getting directly connected with the cloud. Okay, it is getting connected with some edge devices. Okay, now edge devices gets connected with the cloud. Now, what is edge device? Any device that you can touch, you can feel, you can experiment. Okay, for example, if you take a retail store, the point of scale device is an edge device. Your mobile phone, your smartphone is an edge device. Okay, for example, similarly you can find so many edge devices. What difference is, I told about IoT sensor. IoT sensor typically doesn't have any memory, bigger memory or storage or processing power. So IoT sensors do not or cannot be categorized as edge device. Okay, maybe they collect the data and transmit the data, but they do not do any processing. But edge devices have the memory, have the storage power capacity, have the processing power, then other capabilities also. Okay, for example, if you take a Raspberry Pi is an edge device. Why? It has 1 GB memory. It has processor inside. Okay, so today we have GPU, CPU, TPU, tensor processing unit, VPU, vision processing unit. So there is a difference between this low-level edge device and the middle-level edge device. So some people used to categorize like this. Okay, the low-level devices that are IoT sensors, IoT actuator, IoT chips, controllers, all these are edge devices. These middle-level edge devices, they call it as fog devices. Why fog devices? It has the processing power, it has the storage power, it has the memory power. Why all these things are needed? When these IoT sensor devices that are at the very ground level send the data to the edge devices or fog devices, these devices can store the data, can process the data, can make sense out of the data. Okay, so that is the main difference between this lowest level IoT devices, IoT sensors, and middle level IoT devices, IoT edge devices. Okay, so that you have to understand. Okay, so when we say IoT sensor, they collect the data, transmit the data, but they do not do any processing. But edge devices, that is IoT edge devices, will do the processing, will do the analytics. Okay, so that is the difference you have to understand. Now you can categorize any device that has some processing power, that has some memory power, that has some storage power, can be categorized as edge devices. Okay, and all the sensors at the lowest level, you can call it as IoT sensors. They are not typically called edge devices. Okay, because they do not have processing power. Now, one of my PhD students several years back, okay, not now, several years back, he created a edge devices in his home. He put 10 or 15 sensors. Then he put IoT Wi-Fi gateway. He put a smartphone. He put his laptop. He put 3 or 4 Raspberry Pi devices. He connect everything. He connect everything. So all the sensors that are inside the home send the data to these devices. Okay, Raspberry Pi device, IoT gateway device, laptop, mobile phone, refrigerator, whatever device that has some memory power, storage power, can get the sensor data and they will do some kind of processing. Okay, so what is the advantage of all these things? Today, the use case is like this. Okay, this is an use case. That is the first use case for edge computing. Why edge computing is necessary? Okay, that's a research paper published in IEEE by an Indian professor, but he's worked for Carnegie University, USA. Okay, so in the foreign countries, there are roads with electric poles along the roads. In each electric pole, they have Wi-Fi gateway. Okay, then there are signals, and above signal they have kept CCTV cameras. Okay, these CCTV cameras capture all the images of the people who are crossing that signal. Okay, pedestrians crossing the signal. Okay, so CCTV cameras capture the images of the people who are crossing the road, crossing that in that signal. Okay, number of people crossing that, speed, at what speed the people are crossing the signal. All these things are captured by the CCTV cameras. Then these CCTV cameras sends captured images to the nearby Wi-Fi gateways. Wi-Fi gateways are attached to the electric poles along that road. Okay, so these Wi-Fi gateways have the analytics platform inside. So all the images that are captured by the CCTV camera are transmitted to the Wi-Fi gateway. Wi-Fi gateway is situated very near to that signal. Okay. So Wi-Fi gateway is there in that electric pole. So this electric pole based Wi-Fi gateway collect all the images that are coming from the CCTV cameras and they do the crunching there. Okay, they do the crunching there. What it will do? It will do the crunching and it will come to the decision, and immediately it will send a message to the incoming lorry driver, vehicle driver, car driver, saying that this many people are crossing the road at the speed, at this much speed. So please reduce your speed. Okay, so that is the first use case for edge computing. Why? If you send all the image data to the faraway cloud, by the time the lorry would have crossed the signal. Okay, so everything has to happen in nanoseconds, milliseconds. Then only that data has some value. Okay, so what is edge computing? You are not sending the data to faraway cloud. Instead, you are sending the data to nearby edge devices. For example, we all know about the edge, that RK Setu application that are getting posted in our cell phone. So when we are out, if somebody is infected with COVID-19 or approaching us, immediately we will send a notification in our cell phone saying that somebody with COVID-19 infected is approaching you, so please run away in the opposite direction. That is the message you get it in your cell phone. How it happening? We all know the process. That infected person would have given all the details. that are stored in the cloud. MySQL database, that's a government cloud in Delhi or in Kurgan. So it goes to that cloud, and the message comes back to the person. Suppose I am in Bangalore, you all know about the distance between Bangalore and Delhi, maybe around 2,500 kilometers or 2,000 kilometers. So you think about that. The message starts from Bangalore to Delhi, then the processing happens in Delhi cloud. In the cloud, the processing happens, then the response comes back to the person who is in Bangalore. By the time that infected person would have crossed you. So, timeliness is very, very important. That's why edge computing is gaining popularity these days. And in the days to come, you will hear more about edge computing, because cloud computing slowly and steadily will come down, at least for real-time application. Any application, any service that has to be done in real time, that has to be done in quickly, immediately, involve edge computing. Okay. It won't go to cloud computing, okay, because of the distance, latency, network latency, okay. If the network is slow or the cloud is not working, you are done. Your cell phone will not work, right? So how to avoid that? You are empowering your CCTV cameras, or you are empowering your smart cameras, smartphones, to have the processing application inside your cell phone, so that when somebody infected with COVID-19 approaches you, immediately your phone will process that, and within nanosecond you will get a message saying that run away from that place. Okay, so that is called edge computing. So any application, as I told you, that means real-time information, real-time notification, real-time messaging has to go through edge computing or real-time computing. So, in short, whatever they do the cloud, whether it is a public cloud or private cloud or local cloud, whatever it is, for accomplishing real-time computing or real-time application or real-time data capture, real-time data storage or real-time data analytics or real-time decision making or real-time action, you have to do on edge computing. Okay. So why it is so popular, getting popular? For your information, it's a statistics. Okay. For example, Google has the largest number of servers in their cloud service, maybe around 9 lakh servers across the globe. Amazon has 4 or 5 lakh servers. Okay. Similarly, Azure has 3 or 4 lakh server, IBM has that. So totally with Alibaba Cloud, Google Cloud, NTT Cloud, whatever a public cloud, you sum all these cloud, it will come around 20 lakh servers. Okay, 20 lakh servers. But you take, as I told you, we have billions of connected devices. When I say, for example, my cell phone has 8 GB memory, my laptop has 16 GB memory. So you sum all these memory, storage, processing capabilities, we have billions of connected devices. That means it's a huge amount of computational power, storage power, processing power are with these edge devices. Whereas we have only 2 million servers in the, if you sum all the cloud servers across the globe, okay, 2 million. It may go slightly go up in the days to come. Even if it is, it will be around 2 million or 2.1 million servers. But in the case of devices, we have billion. 1,000 million is 1 billion. Okay. So think about that. In future, we will have edge computing bigger scale. Okay. That is the point I would like that. And one more thing I would like to tell here is this one. Okay, so by 2022, 25. Yesterday I read it. 175. It is there. In 2022, 840 zettabytes will be generated. Okay, out of that, 840 zettabytes will be generated in edge devices. Only 84 zettabytes are going to be generated at the cloud. Okay, you can see the slide. Okay, total amount of data that are going to be generated at the edge devices or at the ground level physical devices is 840 zettabytes. Okay, very less number of data are going to be generated in cloud. So there will be more processing happening at edge devices. Okay, and I will go to the next slide. This is a slide that clearly indicates why we need to go for edge computing. Think about that. Cloud latency is more than 100 milliseconds. Okay, and that means if you have a cloud in Chennai, if you have a cloud in cloud center in Bangalore, if you have a cloud center in Mumbai, if they are interacting, they will take more than 100 milliseconds. Okay. Now, you think about edge devices that happens in nanoseconds. Okay. Nanoseconds. Okay. That is the advantage of having edge devices. Okay, so you can go through this slide. You can clearly understand how the latency is between cloud centers and between edge cloud. Okay, so when I say edge cloud, tomorrow the cloud will be generated using devices, not by server machines. Today, all our typical traditional cloud centers are made out of server machines. Okay, Dell server, HP server, whatever it is. But that is not the case anymore. In future, all our devices within our home, within our hospital, within the hotel will combine with one another, and they will generate edge cloud. So, when we have edge cloud, edge analytics can be accomplished easily. Why? Because even if one edge device cannot handle all the data generated by IoT sensors, we can involve hundreds of devices, thousands of devices to crunch the IoT sensor data quickly, concurrently. Okay, that is the advantage of having edge devices in a cluster mode, in a cloud manner. Okay, so there will be more talks, more preferences on edge cloud rather than typical traditional cloud. Okay, slowly computing will go down, and on the other side we will hear more about edge cloud. Okay, so when I say edge cloud, it is not only out of devices. You can create edge cloud using server also. So for your information, sometime back there was an agreement between Jio and Microsoft to create 1,000 edge cloud centers across India. Okay, these edge cloud centers are very small cloud centers. Typically, in a traditional cloud center, there will be thousands of server machines. But in the case of edge cloud center, there may be 10 servers, maybe 100 servers. Okay, small number of servers will be there in edge cloud. Why edge cloud? It is very near to the consumer user. Okay, so that user request can be processed quickly, and the reply will come back to the user quickly. Okay, so that is the advantage of having edge cloud center very near to every building. We have an edge cloud. Every campus will have an edge cloud. Every hospital, every manufacturing floor will have an edge cloud. Okay, so that any kind of information creation will be subjected to analytics, to artificial intelligence toolkit that are there in the edge cloud. That edge cloud will come out with the answer for that quickly, so that the insights can be leveraged by the devices, machines to act upon with all the clarity and alacrity. Okay, so that is the advantage of having edge cloud. So I have written why we have to do analytics on edge cloud for real-time enterprises. Okay, so as I told you, real-time analytics cannot be done to traditional cloud. Okay, for example, very good example is self-driving car. Okay, self-driving car. There are so many cameras inside the car. These cameras are capturing various aspects of that road, so that camera data will be subjected to real-time analytics by the analytics platform that are inside the car. Inside the car, that car will do the car system will do the analytics immediately, and it will accordingly help the car to manipulate through the road. Okay, and without having an analytics platform inside the car, you cannot have a real-time analytics capability. If you send all the CCTV captured images to far away cloud, by the time some accident would have happened for the car. Okay, so for real-time surgery, for self-driving cars or autonomous cars, we have to have connected car. We have to have checking the real-time analytics platform inside. Okay, so similarly, VR, virtual reality, augmented reality, mixed reality. These are some of the video on demand applications in future that needs some such kind of local analytics, real-time analytics, proximate processing. Okay, so I have written about that. So in some other talk, I would have indicated why you should not, why you have to do analytics on traditional cloud, but why you should not do real-time analytics on faraway traditional cloud. You have to do analytics on your edge devices, then only you can get real-time analytics. Okay, so streaming analytics at the edge. For example, if you put a pulse meter, respiration meter, or blood sugar monitor in your body, you can have multiple sensors attached to your body, and if you have a cell phone in your pocket, the sensor will collect all the data about your respiration, about your pulse, about your sugar level. Then if there is any sudden spike on the sugar level, immediately the sensor will send the data to the cell phone. In the cell phone, you have internet connectivity. So the cell phone immediately will send a message to your spouse or to your family doctor saying that there is a spike in the sugar level. So that is possible. So that is called streaming analytics at the edge. Okay. So by combining multiple sensors, using sensor fusion algorithms, you can take a decision. That decision can be conveyed to the concerned person to act upon with the speed. Okay. That is possible through streaming analytics at the edge. Okay. Now we have to have artificial intelligence at edge devices for intelligent enterprises. Okay, by using edge computing, your latency is almost nil. Cloud, your latency is very less. And another thing is your data security. If you send the data through the internet, the data is at risk. Somebody can hack your data. Yes, the data is traveling through the public open internet. But in the case of edge computing, you are not sending any data through internet. Instead, you are sending the data in internet only. That means no outsider can come inside to steal your data. Even if he is trying to come steal the data, by the time the data would have reached the concerned device to act upon quickly. Okay, so that is possible. So reduced latency for data analytics by edge computing, by edge devices, scalability. You can add hundreds of devices very quickly. Okay, but that is not the case with the traditional data center. Virtual machines take 2 or 3 minutes, may take 3 or 4 seconds. For biological sector, it will take a couple of hours. Okay, so but in the case of devices, you can do it. You can scale. Horizontal scalability can be accomplished very quickly. Okay, explain why edge computing is carrying security. Okay, reduced bandwidth usage. You are filtering out all the irrelevant routine repetitive redundant data at the edge itself. You are sending a very relevant data to cloud. You are filtering out all the irrelevant data at the edge. That's why you are saving the expensive bandwidth. Okay. For example, you created every day by Facebook, most of them now, that is around 80% of the Facebook data are useless data, general data. Okay, but still there are 15% of the data that can be utilized for doing analytics to come out with some sort of pattern, some sort of insights, information, knowledge. Okay, so reduction can be accomplished through edge devices. Okay, so there are other advantages of edge computing. That's what I have indicated here by putting artificial intelligence toolkit at your edge devices. For example, when Gal did an intern under me, she developed a robot. In that robot, she was installed with a lightweight version of TensorFlow. TensorFlow is the Google artificial intelligence toolkit. Okay, that robot help the people who are going to retail store to identify the shelf for the particular item. Okay, somebody wants to go to the particular shelf and he wants to buy some particular item, then that robot will lead the shopper, retailer to that particular place quickly. Okay, so that sort of novelty can be accomplished through edge-based edge-based robots. The robot you can have artificial intelligence capability. Okay. Again, this is a very interesting thing. So I don't know how many heard about containerization. So management is in a bit of a project wherein he's using containerization. He's using Kubernetes. Kubernetes is the containerization platform. Okay, that platform helps to manage containerized application. Okay, so there is a lightweight Kubernetes. Typically, Kubernetes is used for creating containerized cloud environments out of server machines. Okay. So we are slowly and steadily moving away from virtual environment to containerized environment. So we are essentially today using OpenStack, cloud operating system, cloud management platform for setting up sustaining cloud environment, but slowly and steadily, as we understood the significance of Kubernetes, people are moving towards containerized okay. Load balancing, so many will come as well. Most about that. Okay. So what I'm trying to tell is now we have heterogeneous devices. Multiple manufacturers. Okay, some devices may be manufactured by Sony, some are through Hitachi, some are through other manufacturer, original equipment manufacturer. They will use different data formats like CSV, JSON, binary, text, XML. Okay, so many. If it is a healthcare device, KHL 7, FHRI, there are so many data formats. Okay, then there are so many data transmission protocols. Okay, by different devices. So in such a heterogeneous, complicated environment comprising hundreds of thousands of different and distributed and decentralized and disparate devices, how to bring a kind of semblance, how to bring a kind of uniformity, how to bring a kind of homogeneity. So containerization is the option. Install containers in each of these devices will interact seamlessly and spontaneously. All the heterogeneity induced complexity by just putting containers inside the devices. Okay, so what I am trying to tell is how to create a edge device cloud, how to create a cloud out of edge devices, how to create a cluster out of edge devices. One of the primary option is containerization. If you put container inside the devices through that container abstraction, all your devices can seamlessly and spontaneously interact with one another. Okay, as I told you, my student put containers inside each of these devices in order to establish a seamless connectivity between multiple different devices. Okay, so these devices can interact interoperably through such kind of containerization enablement. Okay, Docker is the containerization enablement platform. Now, when we put containers, the second thing we need to do is how to manage that container, how to automate the container lifecycle management, starting a container, running a container, killing a container, managing a container, governing a container, putting a policy, patching, updating, okay, enrichment, security, governance. So many things have to be done on these containerized devices as well as containerized application. How to automate this process? Kubernetes is the container lifecycle management platform, container orchestration platform. This platform can easily create containerized edge cloud. Okay, so all the edge devices will be containerized, and this will be Kubernetes managed. So when we have Kubernetes managed edge cloud, it is easy to remotely monitor your edge cloud. For example, you take an oil rig, or you take any rough and tough environment wherein it is very difficult for people to go and attend the devices. Okay, so in faraway place, in say in the midst of sea or in the midst of forest or in the midst of places wherein some tough people are living. Okay, how to manage them remotely through such kind of containerization, through such kind of Kubernetes enablement, through such kind of edge cloud. Okay, so that's what I would like to insist here. So in future, when we think about forming edge device cloud, containerization and Kubernetes plays a very, very vital role over there in setting up this containerized cloud. It simplify and speed up the process of setting up and sustaining edge cloud. Okay, so that's what I have indicated here. There are forming edge cloud is not a straightforward. It is not an easy or rosy thing. Instead, it involves lot of things that difficult things can be simplified and streamlined through Kubernetes. Okay, so I have indicated all these containerization, Kubernetes, microservices enabled here. Okay, so why we need containers, why we need Kubernetes, I told about that. Okay, containers host microservices. You can create multiple applications through multiple containers by composing multiple containers. That is multi-container application. If you compose multiple containers, these containers can run on multiple places. One container can run Chennai cloud, another container can run on Bombay cloud, maybe other places. So if you combine them, you will create a composite application. You will get a business application. Okay, for example, you take, as I told you, Flipkart. If you put some application in Chennai cloud, cloud center, so Chennai user can get the response very quickly. Instead, if you put everything in Delhi cloud, Chennai users will find it very difficult to get the response within the stipulated seconds. Okay, so that's why distribution is very important. How to enable such kind of distribution through such kind of centralized monitoring enabled through Kubernetes. Okay, so all the enterprise scale applications are slowly and steadily moving towards such kind of containerization, such kind of Kubernetes enablement. So that is called cloud native computing. You will hear more about cloud native computing. You will hear less about cloud computing anymore. Okay, so cloud native computing primarily composing three ingredients: containerization, microservices, and container orchestration platform. Kubernetes is one of the popular container orchestration platform. 82% of the companies, corporates across the globe are using Kubernetes. The competition is Docker Swarm as well as Mesos, Apache Mesos. Okay, these are the competitors to Kubernetes. Of course, Kubernetes is much more powerful, much more pioneering, path-breaking compared to the competitors. That's why I was insisting on Kubernetes. So that is about cloud native computing. So here applications will be composed out of microservices. All the microservices will be containerized. Containerized images will be available in container repository like Docker Hub. This Kubernetes will fetch those containerized images, instantiate them into container instances, microservice instances. Combine these microservice instances, you get an application in minutes of the time. So technologies are very powerful nowadays. It automates most of the manual activities. Once upon a time, it was taking 100 days. Today, you can finish it in 10 minutes. Okay, that is the power of technologies. Several technologies have come and gone by without contributing anything substantially for the upliftment of society. So technology choice is also very important. When I talk to my PhD students, I used to tell them, choose the technology that will be there at least for the next 5 or 10 years, so that when you finish your PhD, you can proudly tell the audience saying that I have worked on this technology. Okay, so technology choice is very important. Here, the point I would like to insist here is the future belongs to cloud native computing that takes care of not only cloud application, but also it will take care of your edge application, your edge intelligence applications. Your devices will become intelligent on device AI. So edge AI. Okay, so I have written something about that. Cloud native container functions. So this is cloud native means edge computing. Now I told about that. Typically containers are running on cloud environment, but now with the cloud native meets edge computing, containers are moving towards edge devices. Your cell phone, your smartphone, your Wi-Fi gateway, your medical instrument, or your defense equipment, or your drones, or your robots, or your game consoles, or anything, any device you take it, therein containers will be there. Therein microservices will be there. Therein that devices will be managed remotely, centrally through Kubernetes. Okay, so that is the conceptual thing behind this cloud native edge computing. I think 1258. Okay, so I can go on like that. So 5G is there. 5G plays a very important role in edge computing because you can go through that slides if you want. You can get it from me. Okay, so one small edge computing, edge AI product that we have developed in Geo, and we got the best price also across India. Typically, in the IT industry, if you go to office, you have to carry that what is that identity card in your neck. So you swipe that card in the door reader, and the door will open. You will enter inside the office, and you will start your work there. Okay, what is happening behind? When you swipe your card, your employee data and other details are being captured by the edge reader. Then it will send it through internet to the cloud application. Suppose you are in Bangalore, but your cloud is in Navi Mumbai. Okay, so it goes to Navi Mumbai Cloud Center. In the Navi Mumbai Cloud Center, there's the attendance application is running. In the attendance application, they have a database. So all the data that are captured by this door controller will go to the MySQL. I don't know which database it is. That database process that. If it is matching, then the response will come from Navi Mumbai to Bangalore. Then the Bangalore door will be open. You will enter inside that. The question is this: suppose the network is slow. Suppose the cloud is down. Then you have to stand outside permanently. Okay, the door will not open. So what is the solution? Employ edge computing. What does it mean? Instead of sending your data to faraway cloud, instead you create a edge cloud locally. Within that edge cloud, you put a database. In the database, you can put all the employee database, and we have developed that such a controller that sits in every floor. Okay, so when you stand in front of the door, you swipe the card, that data will be captured by the door reader. Door reader will send the data to the controller. That controller sits in that floor only. So that means maybe a couple of meters from that door reader. Within a nanosecond, your data will reach that controller. That controller has the capability of wireless connectivity as well as wired connectivity. So wireless is not working, wired connectivity. Wired is not working, wireless connectivity will work. Okay, so therein your data will be processed very quickly. Within a nanosecond, your door will open. Okay, that is the edge computing product. We have, as I told you, we have used microservices inside the door controller. That controller was fully developed by our team members. Okay, it's a very small Raspberry Pi based controller, very small, handy. Okay, it's very less price also, maybe 3,000, 4,000 rupees. So it can accommodate 55,000 employee data, and we have put it inside the containers only. It supports microservices architecture as well as it supports event-driven architecture. It has so many features. Okay, I just told about only one feature. Get the data of employee, process the data, match the data. If it is matching, the door will open. You are through. Okay. Now another thing is we have put CCTV camera near that door, so you need not carry that ID card also. You just go casually, you need not stand in front of the camera, because camera accordingly turns around to your direction, to your face, and it will recognize your face and the door will open. Okay, so that is the edge based, and we have put artificial intelligence, deep learning algorithm inside. Okay, that's why I use the word edge. Okay, it is inside that controller. Controller is in every floor. So one controller can handle several doors. Okay, so that is the edge device developed by Geo, and it is available. It is running in 100 doors in one tower. Another thousands are getting deployed, and that is as far as our knowledge is concerned, that's the first device, edge AI based, smart, secure attendance access control system, ACS system, that is developed in India. Okay, so that's an edge-based ACS control system, and we have incorporated face recognition also. FR also it's attached. That's a powerful system. Okay, so that is typically AI based. Okay, so that's what I have used the word AI. Now we are using blockchain also. Blockchain, as I told you, it is a security enablement technology. Nobody can hack the data, because all your personal data are there in the database. Your face is stored there, your employee data, when you came to office, how many times you went out of office for roaming around or coffee house, or maybe spending some time with your friends outside. All these things can be captured. Okay, you cannot cheat your manager anymore, because manager will know when if you are sneezing also. That is possible through such kind of edge AI systems. So that will be there in that device. Blockchain is the database that we are going to use for security. Another thing I wanted to tell is we are clustering multiple controllers also. That has not yet been done. The proposal is given to the top management. When we get the approval, we will embark into the clubbing together multiple controllers, so that even if one controller goes down, other controller will come to the rescue. Okay, so that is the possibility of we can we have identified several other interesting futuristic use cases on this edge product. Slowly and steadily, the team will implement that. Okay, so thank you so much for listening to me for such a long time. If you have any question, you can ask me. I don't. Otherwise, you can send your email ID.
Thank you, Dr. Pedro Raj Chelliah. And first, before I thank you, please have a cup of water, because you have been continuously talking for more than 1.5 hours. And it is something like through your lecture, you have really mesmerized all the participants, who are participating in this lecture, both in India and abroad. And it is, I thank you, and profuse, it is the way in which you have explained, defined, described in, in such a manner that the people, the participants, and the students who have understood edge computing in a very appropriate manner. And you have covered very effectively the digital implications by 2020, even though that one slide has conveyed everything. You said it by millions of software services. On that one line alone, you have talked about more than 15 minutes. Second is on billions of connected and cognitive devices and trillions of digital entities. Like on the other day, when the chairman of the Reliance Jio platform, Shri Mukesh Ambani, talked about it in the global AI summit, 2020, he talked about data is oil, and both oil and data have to be, refined and for its usage. And today you said it that data, it has to be analyzed, it has to be used, it has to be refined, and for that the edge computing is the only way to go about it. And this is a very important thing today. I hope that many students who would like to become the startups have immensely benefited out of your lecture. You talked about artificial intelligence, why, where, and how, and why not, and how not. All these questions, 5 Ws and 1 H, you explained very effectively. You talked about integrated analytics. You talked about IoT in a very analytical manner. You done about enterprise mobility, and talked about you talked about cloud native computing, fog edge computing, and you spend very effectively the microservice architecture and event driven architecture and augmented and virtual reality, and also that containerized clouds. I think this lecture today has given and sent out a lot of innovative ideas to all the participants, and the students who would like to establish startups using open digital technologies for self-reliant India. They have got really benefited out of your 1.5 hours lecture, your talk, your address. We thank you, and we from our bottom of our heart, and we would like to closely associate with you for our venture, which we would like to come in future. And the Center for Informatics Development Solutions and Applications will always remember you for your participation for this. It's a very important lecture which you have given through this platform, Edge AI. In order to summarize that, what you have talked about it, you said it very clearly that Edge AI is the future of IoT. And as per the report goes, there is a real need for developers worldwide, around 1 million developers in this new market. I think with your lecture today, which has really mesmerized and also activated many of the the students and potential students and entrepreneurs who would like to get into startups in open digital technology, would have really got activated, and I'm very thankful for you to deliver such a very innovative lecture today. And you very rightly said it that by 2025, global edge computing market is forecasted to reach about $1.12 trillion by 2023. And IoT, edge computing, and artificial intelligence are going to rule in future. And convergence of between programming on IoT devices and programming on the cloud of big data and artificial intelligence will allow practitioners to unleash their creativity. So we are very happy that for organizing these very important lectures today by you for non-stop delivery of your address is unprecedented. And you also very rightly said it that advantages of artificial intelligence enabled decision making at edge level. And you also come out with large scale of use cases you said it very clearly that how South Korea and China and overcome this COVID-19 by applying artificial intelligence at using edge computing. So you also talked about several drivers of edge computing and edge artificial intelligence. Talked about privacy, talked about security, talked about latency, talked about load balancing, and many such drivers which you have talked about it, and we are very happy about it, and which is also now motivating data scientists, machine learning engineers, front-end developers, network operations, development operations, IoT developers, and back-end developers. So this 1.5 hours lectures is something like a fulfilling, lectures, and I'm very happy that this Saturday, it is a fruitful Saturday on the topic Edge AI, Edge Artificial Intelligence, and Dr. Pethuru Raj Chelliah, you have explained in such a manner that you yourself has exhibited as an edge AI for us. It's a knowledge warehouse. It is a knowledge mission, which you have said that Dr. Pethuru Raj Chelliah is an edge AI. So Center for Informatics Development Solutions and Applications of the Soviet Institute of Engineering Technology, on behalf of the faculties of the Soviet Institute of Engineering Technology, on behalf of the Vice Chancellor of the deemed university, on behalf of the Chancellor of the deemed university, and on my behalf, I we appreciate and thank Dr. Pedro Raj Chelliah for your very innovative, powerful awakening address on Edge AI. Thank you very much. Thank you very much for all the participants, both in India and abroad, for attending this, seminar. And Center for Informatics Development Solutions in Agriculture, every Saturday at 11:30 a.m., we organize, addresses by eminent scientists, technocrats, and educationists, academicians, researchers, both in India and abroad, for the benefit of our Indian participants. Thank you very much. Thank you very much. And next week on Saturday, we will be having, lecture by Mr. Rajshekhar, Deputy Director General from National Informatics Center, to talk on data governance. Thank you very much.